Okay, lesson 1, graphically representing data. So the thing is with statistics, if you've got a list of numbers, whatever you're looking at, if you can take those numbers and put them into some kind of a graph, you can make interpretations from there. Okay, you can see things better when you're looking at a picture rather than just a list of numbers. So we're going to spend our time, okay, on quantitative data in a single variable for right now. Later on in the chapter, we're still going to be talking about quantitative data, numbers, but then we'll bring in another variable. We're talking about bivariate data. So right now, single variable, univariate. One variable is often collected in order to understand how characteristic of a group differs amongst the group members or between groups. When we ask a question like, how old is a typical fast food worker, it is helpful to take a survey and then see graphically how those ages differ amongst. So like I said, if we just have a list of ages, we really can't interpret too much from just a list of numbers. But when we put it in a graph, you can start to see patterns. It says Charlie's Food Factory currently employs 28 workers. Those ages are shown below on, dot plot. That's what that's called, dot plot. Okay, big deal there. You see a bunch of dots. So based on that, we're going to answer the question. So it says ages of workers at Charlie's Food Factory. And those dots represent the number of people that are those ages. So how many of the workers are 18 years old? So I'm looking at my scale, 15, 16, 17, 18. There are 4 workers there. Then it says, what is the range of those workers? So the range is the high minus the low. So the oldest person is 42, minus the youngest person is 16, and we end up with a range of 26 years. It says, would you consider this distribution symmetric? So when you look at this whole graph in its entirety, okay, from left to right, the whole thing, does it look symmetrical? What do you think? No. Okay. So it's not. So when I look at it, it kind of does this. And what that means is it's skewed. Okay. If it's not symmetric, it's skewed. Okay. So would you consider this distribution symmetric? No. It is skewed, and it has a direction. And the direction is where the tail is. So the tail goes to the right here, so it's skewed right. Skewed means you've got a chunk of data either on the left side of it or on the right side of it, not right in the middle. If it's symmetric, you have your chunk of data right in the center. Okay, then it would be symmetric. The mean, or the average, for the worker is 22 years old. So they're telling us they've calculated that. Why is the average not representative of a typical worker at Charlie's Food Factory? What's a typical worker's age at Charlie's Food Factory? What do you think? 20. Okay. When I look at 20, those have the most. So that's our typical age. Typical age, okay, would be 20. That's where most of them are. And then even look to where there's even more, okay, even less than that. Okay, so a typical age would fall anywhere between that 16 and 20. Definitely not to 22 for a typical age. Okay, that's what we're going to end up hearing about, that the mean is not necessarily very representative of your data. Because let's think ahead here. What would be pulling our mean up to that 22? Brian? Yeah, this big guy up here, okay, and you use that term outlier. You guys have probably learned that in the past. That 42-year-old, boy, he's old, or she's old, is pulling that mean up, okay? I'm clearly not 42, not even close. So, let's go to the next one. So the farm is studying the weight of baby chicks after 1 week of growth. They find the weight in ounces of 20 chicks. The weights are shown below. Construct a dot plot on the given axis. So I'm going to pause the video and we'll go ahead and construct that dot plot. Okay, I'll turn it back on once. Okay, so your dot plot should look like that. And let's go ahead to exercise 3. Says the following histogram. Okay, so we're talking about a histogram here. So the ages of workers at Charlie's Food Factory from exercise 51, but in a different format. Okay, so on the front we had a dot plot to represent their ages. Now we put that information into a histogram. This is not a bar graph. Okay, what's the difference between a bar graph and histogram?
Histogram is like more ranges.
Potentially. What else? Something like not real mathematical, but makes a big difference. Think about what a bar graph looks like, and then take a look at that histogram. What could you say about the bars? There. Yeah, that's the biggest difference. Okay, bar graph. The bars have spaces in between. A histogram, they all touch each other. Okay, the bars are right next to each other. Okay? So a histogram is not a bar graph. So it says how many different workers had ages between 19 and 21 years? How many? 11. Okay. Right here, 19 and 21. 11. What is the disadvantage of a histogram compared to the dot plot on the front? What's the disadvantage to having this data in histogram as opposed to the dot plot? Yeah, you can't see the exact ages. You have a range of ages. Does the histogram have any advantages over the dot plot? What do you mean? We still could see that on the dot plot. It's not a huge difference, and it's not like wow, but
it might feel like easier to draw more on an Instagram, like that's
okay, definitely, yeah, because you've got those ranges. Okay, it won't have to be sort of long. Yeah.
Easier to see the number of workers.
Yes. Okay? Because on the dot plot, what do you got to sit and do? Count those dots. Okay? Where right here, you can see, okay, the frequency right on the left-hand side, and you're able to read the total frequency. Okay? No counting dots. All right, exercise 4. So now we're going to take, and we've got Arlington High School boys basketball team compiling a record of 15 and 5. That means 15 wins, 5 losses. Total points scored by the team for each of their 20 games. All right, so we have 20 games here, and their scores are listed. Now we're going to take this list, we're going to put it into a frequency table, and then we are going to construct our own histogram. So let's go ahead and fill in, I'll show you how to fill in the table first, and then we'll pause the video and do some work, and then we'll come back. So at 76, 76 obviously falls in between 70 and 79. Big thing about tally marks, okay, kind of a pet peeve of mine, when people don't make the tally marks like this, groups of 5. Okay, groups of 5, 4 vertical, the 5th one on whatever diagonal, doesn't matter which diagonal you go on, but groups of 5. Okay, cross them out as you go. 70. Alright, so we'll pause and go ahead and fill that table in. Alright, so we're going to fill in that frequency column, so 3, 8, 6, 2, 0, 1. Now to construct a histogram, we're always going to put our intervals down on the x-axis, and we're going to put our frequency along the y-axis. We're going to put 0 in the corner there. Now, there weren't any games between 0 and 39 points. So in order to take that into account, we're going to put a break in the graph. So I think we probably could do an interval of a width of 2 boxes wide. So to account for nothing that's between 0 and 39, or 0 up to 40, we're going to put that little break in the graph, and then we can start our first interval from 40 to 49. I like to kind of write mine vertically because then they just seem to fit in a little bit better. And then my highest frequency is 8, so we probably could go every 2 boxes to 8. You probably could have even stretched it out even a little bit more, okay, to take up as much of the graph as you want. So just make sure that you start your first interval, 40 to 49. Don't start it where the break is. Make sure that you are in the interval from 40 to 49, and there were 3 games. Make those bars nice and neat. Okay, go ahead and complete your histogram. Okay, so your histogram should look like that, and we're going to go over to lesson 2. Score tiles and box plots. So another visual representation on how data is distributed comes in the form of a box plot. Okay, sometimes a box plot is called a box and whisker plot. We create a box and whisker plot by dividing the data up roughly into quarters. Okay, quarters, 25% of the data, quartiles. So 25% of the data. So shown below are 16 students, right, grades that they got on a math quiz. What is the median for this set of data? So when you find the median, the numbers must be in what? They must be in order, least to greatest, must be, okay? So to find the median, least to greatest, and the median is the middle. Median's the middle. So I always start out with, first I scan the numbers to see these are in order for us. And if you cross off a high and a low pair at a time, a high and a low makes a pair. Okay, and keep doing that. Now because we have an even amount, okay, we can't cross off a high and a low pair. We're left with 73 and 74. So what's the middle of 73 and 74? 71. Yep. Okay. Right there. That's the middle. When you have an even amount of numbers, you're going to have to find the middle. When you have an odd amount of numbers, you'll be left with the middle number. Find the range. okay, of the data set to find is the difference between the largest and the smallest. We did that in our last lesson, so high minus below. So it's, what is it, 98 minus 52, which is what? 46. So we got the range. Now it says, what is the median of the lower half of this data? And that's known as the lower quartile. So the median of the lower half is called the first quartile, quartile 1, lower quartile, lots of synonyms. Okay, so we're thinking that it is 66. Nope. Yep. Okay, so if we cross off or kind of cover up, you cover up the median and the upper half of the data. So, let's see, did I change colors? So we end up with crossing off a low and a high pair. Okay, we are stuck with two numbers again. So the middle of 66 and 68 is 67. So now, therefore, what is the median of the upper half, known as the third quartile, or Q3, or upper quartile? Do the same thing. Cross off. So ignore the median and cross off your high and your low pairs. And we're left with two numbers. So what's the middle? 83. So can you see the quartiles here? Quartiles. I took the data and split it into quarters. Right here, 25% of the data. 25%. 25%. 25%. To make 100% of the data. So it says the first and the third quartiles are sometimes known as the lower and upper. I did mention that. These quartiles, the quartile, the median, the lowest and the highest values in the data make up something called the 5-number summary. Those are your 5 numbers. Low, high, median, Q2, Q1 and Q3, 5 different numbers. And that's what makes up your box plot or your box and whisker. That information. So it says, using the data set, construct a box and whisker plot on the number line. So my lowest number was 52, right? So let's see how we want to set up our 50. So my low is 52. My high was it 98? I think. Yeah. So median was our median 73.5. Q1, Q3. So Q1 came out to be 67, and Q3 came out to be 83. Okay, so there's our 5-number summary. So the box makes up, or is made up of Q1 through Q3. So Q1 is 67, so about right there. Q3 is 83, so right there. And the median is 73.5, right in there. And we make a box. So this is Q1. The median could also be called Q2. There's Q3. And then the whiskers, we whisker out to the high, which was 98. and we whisker out to the low, which was 52. Boxing is the plot. All right, go ahead, flip it. All right. I'm going to have you guys do that one. Create a box and whisker plot. We're going to do that on the calculator. Okay? We'll show you guys how to do that on the calculator. We'll do that off the video though. Okay, so we'll come back to that in just a second. Medium range, I'm just looking at this next problem. Oh yeah, let's do this one. Okay, so we've got our box and whisker. What's the median? Anybody? Bueller. What do we got? Close. We're going to call it 71. Okay. Median 71. What's the range? What's the high minus the low? 84 minus 53, which is 31. And then it says, what score was greater than or equal to 75% of all the other scores? Where is 75% of the data? Where is that? At what Q? Q3, right? Okay. Here's 25%. There's 50%. There we go. There's 75%. What score is that? 76. Q3 is 76. So Mr. Weemat regularly sets his passing grade on its quizzes to be the score of the lower quartile. What is the passing grade for this quiz? What's the lower quartile? 64, right here. 4 is passing, and we'll skip over that one.